Now, exponentials. We deal with e as if they're exponential. So if we have e to the power of kx, now that's the way the rule's stated in your formula sheet. It could be anything up the top. We won't just get simple 3x. It could be x squared plus 5. It could be sine x. It could be anything. We'll go through a few examples. But basically, this is really chain rule, but we can't be bothered writing it. Whatever your power is, I don't care what it is. If we're deriving exponentials, you look at your power, derive that. So in this case, the derivative of 3x would be 3. The derivative of 5x would be 5. So the derivative of kx is k. Stick it to the front and copy the whole exponential down again. Do not touch the power, do not subtract 1, do nothing else. Simply say, what's my power? Derive it, put it to the front, end of the story. That's exponential functions. So, e to the 3x plus 1. Right? Derivative. Derive 3x plus 1. 3. Leave the sum. That's exponential derivatives. Pretty okay, yeah? Whatever the power is, derive it, place it to the front, leave the rest exactly the same. What it is you're saying that, just if I had an exponential function and I wanted to find the gradient, doesn't matter where I drew a tangent and found the value of the gradient, it would be equal to the value of the function at that spot. So the simplest one is, if f of x is e of x, f dash of x is also e of x. Because the power here is 1x. If you derive 1x, you get 1. So if you have ex and you find the derivative, it's also ex. If you have e to something more complicated, then that derivative comes to the front. Oh, I can't do that because you don't know that yet. Right? So, e to the x squared plus 3. Right? The derivative is, look at the top. The derivative of x squared plus 3? 2x. Stick it to the front. E x squared plus 3. Right? Whatever the power is, derive it, place it to the front, end of story. I'm going to knock off all the things today because we're in flying.
So what if it was 2